In this lesson, we're going to review absolute value and how to solve absolute value equations. So if you remember, the symbol for absolute value is these two bars. And the absolute value of a number simply means how far is that number from zero, the pure distance from zero. So if I asked what the absolute value of 4 was, the distance from 0 would be 4. If I asked what the absolute value of negative 4 was, that distance is still 4. So it's kind of like if you're on the number line, it doesn't matter which direction you're going, it's the pure distance to that number. So from 0 to 4 would be 4 units, and from 0 to negative 4 would also be 4 units. So you can see that the answer to that, the absolute value of 4 and the absolute value of negative 4 is still the same. It's positive 4, which is true of all absolute values. The absolute value of any number will never be a negative number because we're talking about pure distance from 0, and distance is always a positive number. So the absolute value of anything has to be a positive number. So if we are seeing problems like this where we're evaluating after we plug in the numbers, whatever the value for x is, it's telling us to plug that in and then evaluating. So this says the absolute value of 2x minus 8. So I'm going to plug in a 2 for x because that's what it's telling me x is equal to. So I'm going to get 2 times 2 minus 8. So I need to simplify everything inside the absolute value bars first and then take the absolute value of it. So following the rules of order of operations, 2 times 2 is 4. 4 minus 8 would be negative 4. And the absolute value of negative 4, like we said before, was positive 4. If you have more than one absolute value bar, then you do them one at a time. For example, number 5 here. It says the absolute value of x is 2. So all I'm going to do is I'm going to substitute all these numbers for the value. So this is x minus the absolute value of x minus the absolute value of y minus the absolute value of negative 6. So before I can start adding or subtracting these, I need to take the absolute value of these numbers. So the absolute value of 2 is 2. The absolute value of a half is a half. So that minus sign is not inside the absolute value bar, so it's going to stay there. That minus sign is going to stay there. And the absolute value of negative 6 is positive 6. So now I have 2 minus a half minus 6. So 2 minus a half is 1.5. And 1.5 minus 6 is negative 4.5. Now, remember, I've already taken the absolute value bar. So once you take the absolute value of a number, you don't need the bars anymore. So that's how my final answer ended up being a negative. But when I'm taking the absolute value of the number, that's going to end up being a positive. Let's take a look at, let's look at 13. So 13 says 6y plus z. Y is, in this problem, y is a half. And z is negative 6. So I'm going to get the absolute value of 6 times y, which is a half, plus z, which is negative 6, plus the absolute value of y times z, which is 1/2 times negative 6. So now I can simplify this. Well, 6 times a half, half of 6 is 3. 3 plus negative 6 is negative 3. And now I take the absolute value of negative 3, which would be positive 3. I'm going to simplify this side. I'm inside the bar, so I need to half of negative 6, which is negative 3. The absolute value of negative 3 is 3, so my final answer is 6. So if you're evaluating, simplify everything inside the absolute value bars first. Then take the absolute value and then simplify from there. Now, if you're solving absolute value equations, here's what you have to realize. If I if I said the absolute value of x, if I said the absolute value of x is 3, and I said, what is x equal to? Well, the absolute value of this number is 3, then that would mean x has got to be 3. But x could also be negative 3. There's two solutions to this problem. The absolute value of 3 is 3, and the absolute value of negative 3 is 3. So my point is this: when you have an absolute value equation, then there could be two solutions. There may not be, but there could be. If we look at this one here, this x plus 15 equals 37. Some of you guys may have forgotten how to work these, but if you see this absolute value bar, then you automatically need to think, I may have two solutions and I need to work it two different ways. The first way is just drop the absolute value bars and work it like it looks. The second way is drop the absolute value bars and make this number over here the opposite of that number, the negative of that number. So now when I work this, if I take away 15 from both sides, I end up with x equals 22. If I take away 15 from both sides over here, I'm going to end up with x equals negative 52. So there's my two solutions. Okay. Now, if I wanted to work a problem like number 5, see how the 16 is not in the absolute value bars? I need to isolate the absolute value first. So my first step here is I'm going to take away 16 both sides, and that's going to give me 5b plus 9, the absolute value of 5b plus 9. I'm going to minus 16, and minus 16 would give me negative 14. So here is a special case. I have the absolute value of this is equal to negative 14. So I'm going to cover that up just for a second and show you. Remember, the absolute value of anything has to be a positive number. This is a situation that is not possible. The absolute value of whatever is underneath my thumb has to be a positive number, and this is saying it's a negative number. So for this problem, you would say there's no solution. Okay. Let's look at question number 6. 15 minus 2k equals 45, the absolute value of that. So I'm going to work it once just like it looks without the bars. And then I'm going to work it once. And I'm going to make the 45 a negative 45. Okay, so this is possible. The absolute value of this is 45. That's a positive number. So now I've got to work it twice. So I'm going to take away 15 from both sides. And that's going to leave me with negative 2k equals 30. And then when I divide by negative 2, I get negative 15. So there's one solution. Here I'm going to take away 15 from both sides. I'm going to be left with negative 2k equals negative 60. When I divide by negative 2, I get k equals 30. So there's my two solutions. So let's look at a question like number 10. I'm going to turn the page over. It says the absolute value of 3x minus 1 equals 2x plus 11. The absolute value 3x minus 1 equals 2x plus 11. Okay? I'm going to work it two ways. I'm going to work it once, just like it looks, but I'm going to drop the bars. 3x minus 1 equals 2x plus 11. And then the other way, this one's different. It's not different, but it's positioned different. It's presented differently. I'm going to drop the absolute value bars, and I'm going to do the opposite of this, which means I'm going to multiply it times negative 1. So this becomes 3x minus 1 equals negative 2x minus 11, and then I'm going to solve both of these equations. Take away 2x from both sides. I'm left with x minus 1 equals 11. Add 1. And I get x equals 12. Here, going to add 2x to both sides. I get 5x minus 1 equals negative 11. I'm going to add 1. And I get 5x equals negative 10. When you divide by 5, you get x equals negative 2. And there's your two solutions. So absolute value equations have to be worked two ways. Once with the way it looks, and then once with the opposite of the number. So see, if I look at number 11, I just glanced at this. It says the absolute value of 1/3 x plus 3 is equal to negative 1. This is no solution. The absolute value of anything has to be a positive number, and it's not. So this one is no solution. Okay. Absolute value.